Hello everybody, I hope you guys can hear me. If my audio setup isn't perfect, I lost a bunch of data recently regarding OBS settings because of Windows being a little bit of an asshole. So if there's something wrong with the stream, please just tell me. Now, this stream will actually be a two-parter. The first one will just take a few minutes where I actually go through the data. And then afterwards, we will open another one and have a little bit of a discussion. As you guys might have heard, yesterday, on the 15th of January 2022, at around 4 a.m. UTC, there was a major volcanic eruption in the island state of Tonga, about 2,000 kilometers northeast of New Zealand. And it has caused a major tsunami, which has reached parts of the US western coast. It has reached, obviously, parts in the Southern Ocean. It has reached South America, where it actually killed a few people. And the explosion has also caused a major shockwave, which was registered everywhere on the planet, multiple times actually. Now, what many people don't realize is that this is actually a super nice piece of evidence that shows that our Earth is actually a sphere. And I'll just show you quickly why that is. So just for orientation, the explosion happened here. So this is New Zealand down here, you have Australia over here. And the volcanic island that blew up is this one. I won't even bother to pronounce his name because I can't. Okay, so where's my PowerPoint presentation? There we go. So many people actually measured two shock waves. Hang on. No. What the fuck? What is this doing here? Okay, something just happened that shouldn't have happened. Give me a second. Okay, so imagine that this is the Earth. We have our explosion down here, and we have the antipodal point, which is the point that's directly opposite of the explosion on the surface of the Earth. And then we have a random observer that's placed anywhere on the sphere. Now this observer actually hears two shock waves caused by the explosion. First shock wave is caused by the shock wave directly traveling from the explosion to the observer. And a few hours later, a second pressure wave will be observed, which is the shock wave actually going around the other side, hitting the antipodal point first and then the observer. So in terms of time, imagine if the shock wave happens at a time of t equals 0. A certain time will pass, and then you will see shock wave number 1 and shock wave number 2 a little bit later. In between those points, the shock wave will actually travel through the antipodal point. It is important to note that the distance between shock wave number 1 and the antipodal point is the same distance as between the antipodal point and shock wave 2. And this was actually observed. Multiple people on different continents saw two different points on the surface of the planet. Two different shock waves at different times. Imagine you have three different people on different points on the surface of the planet. One being far away from the antipodal point, one being quite closer, and one being very close to it. Now, this line represents the time when the shock wave hits the antipodal point. When you're far away from the antipodal point, you're closer to the volcano, and therefore the first shock wave is going to hit earlier. Unfortunately, also the second shock wave is going to hit later. If you get closer to the antipodal point, the first shock wave is going to hit later, and the second shock wave is going to hit a little bit earlier. If you get very close to the antipodal point, the shock waves are going to be even closer to one another. And if you're directly on the antipodal point, there will only be one shock wave. Okay. It is important to note that if you take both times from the explosion to shockwave 1 and the explosion to shockwave 2, if the Earth is a sphere, then those times are actually going to be the sum of those parts is going to be identical. Now, obviously the time between, or the actual time on the clock between shockwave 1 and the explosion, that's going to be the runtime of the shockwave. The same can be said for the second shockwave. Now it is important to note that the runtime of the shockwave is going to be proportional to the distance of the volcano, under the assumption that the shockwave speed is constant. This is actually the only assumption that I make in this analysis. And on a sphere, in every case, no matter where you are on the planet, you will always have the fact that the first runtime of the first shockwave and the runtime of the second shockwave are going to be constant. So it's important now that we look into a little bit of the data to see if this is actually the case. Okay. So if you remember that I am often using GeoGebra as my go-to software, I actually just went to Twitter and had a look at what people are uploading. There's multiple people who use their the barometers that they have at home to actually measure this. And in this diagram, which I hope you guys can see. Yes, you guys can see it. Let's just zoom in a bit. The vertical axis on this diagram doesn't mean basically anything. I just numbered every point that I found online and gave it a number. These are not related in any way. But what you see is that the let's just go for this Bryce Norton spot, for example, as an example. That if the explosion happens at a time of t = 0, this scale is in hours. The first shockwave was measured at 15.5 hours, and the second shockwave was measured at about 21 3/4. And if you sum those two numbers up, you end up with about 16.5 hours. Now, as I said, if the Earth is a sphere, then no matter where you are on the planet, the sum of those two numbers should be identical. And I just took the first random 8 data points that I found from people on Twitter who use the barometers and actually gave out the timings on when they noticed the shockwaves. And yeah, they're all pretty similar. So this is a challenge to flat earthers. If this is a flat Earth, then how the fuck is this working? So I guess that's already it. I'm gonna close this Hangout here now and open a new one where I'm gonna talk with my buddies a little bit about this data. So thank you.